Hi Grace, this is Mr. Caslin. I wanted to go over this problem that we got stuck on last time we met. I think we were doing things right. I just was interpreting the answer incorrectly, I think. So let's walk through this. I think we were pretty much there. We had an angle. Now, this problem is tricky because the angle they give you, they're calling it B. In most problems you'll see in most textbooks when you're doing an SSA, they'll give you angle A. So we just have to adjust on this one. So we're giving us angle B is 20 degrees. The corresponding side is 4 units, and the side C is 6 units. So in this case, we have an acute angle that they're giving us, and then the side that corresponds to that angle is less than the other angle. Okay, whenever you have this situation that this side that's across from the angle they give you is less than the other side that they give you, then you have a situation here where you're going to have two solutions. Okay, so we have two solutions. That's because this is only 4 that you could actually swing this. Since we don't know what this side is here, you could also swing this side around and connect it like this, so you'd have two different triangles that you could make in this situation. Okay, so I think we were setting things up fine. The way you set up law of sines and solve them is going well. Here we have 4 over sine of 20 is equal to 6 over the sine of C. So we're just using 2 pieces of our law of sines. We solve that. I think you were solving that correctly. We were getting a C is 30.8 degrees. Okay, but remember, so that would be the acute solution, which would be here. We've also got this obtuse solution, which is going to be 180 degrees minus 30.8. So that's where this two solutions branches out. Angle C can either be 30.8 degrees, or C can be 149.2 degrees. All right, from that point on, start solving this as 2 different problems. We know B is 20 degrees in both cases. So if C is 30.8, I believe that's going to make A 129.4 degrees. These are just degree markings. They don't look very nice here. And then in your other situation here, where angle C is obtuse, that's going to give us angle A of 10.9. Okay, so here's probably where I got, I guess we can say I got confused. It's angle A that we're interested in. So if angle A is wider, that should give us a side A that is longer. And if angle A is not as wide, it should give us a side A that's not as long. I think maybe I was looking at angle C last night, and that's when I was evaluating the length of the sides, and maybe that's what got me off track there. Anyway, so I think we were doing this right. So we keep going down. Remember, both of these cases, angle B is 20. So now you can just continue with your law of sines. Okay, so now we can say we're solving for side A. So side A over the sine of 129.4 is equal to 4 over the sine of 20. Okay, so the only thing we're doing differently is our angle A is going to be different. Here we're going to use sine of 10.9 in our law of sines, and when you solve that, I believe, so this is the one you had on your notes, and we solved and we got 10.07. We'll call that 10.1 units. And when you solve this, you're going to get, I believe, 2.2 units. So it's possible that we were getting these answers and these were right. I was just thinking for some reason that this side was supposed to be longer, but it's not. We're looking at angle A, which is 10.9 degrees. So because this is angle shorter now, that the opposing side should, from here to here, would be 2.2 units. So acute triangles, when the side opposite the angle that they give you is less than the other side that they give you, you have 2 solutions. Hope this helps. Talk to you later.